In 2017, an object passed through the solar system and permanently changed the way we look at space. Its name was Oumuamua. It did not resemble any known asteroid. It showed no traditional comet tail. And most puzzling of all, it accelerated as it moved away from the sun without a clear explanation. For the first time in history, humanity had detected an object that clearly came from another star. Its trajectory, speed, and behavior challenged long-held assumptions about what could travel between stellar systems and still be detected by our instruments. 2 years later, another visitor was confirmed, Comet Borisov. Unlike Oumuamua, Borisov behaved like a typical comet. It released gas and dust and followed predictable physical models, and its interstellar origin was unmistakable. For many scientists, this second case brought a sense of balance. There was now a comparison point, a known reference. Then came 3I/ATLS. When the first data about this object became public, many astronomers felt a familiar unease. The velocity was unusually high. The trajectory appeared abnormal. Early orbital calculations suggested that the object might not be gravitationally bound to the sun. The memory of Oumuamua immediately resurfaced. The question was unavoidable. Were we witnessing another interstellar visitor, or were we once again facing the limitations of early observation and incomplete data? At first glance, the similarities were difficult to ignore. Both Oumuamua and 3I/ATLS were detected late, already moving rapidly through the inner solar system. In both cases, scientists had only a short observational window, few data points, little time, high uncertainty. But the differences were just as revealing. Oumuamua displayed behavior that defied expectations. Its acceleration could not be explained by gravity alone. There were no clear signs of gas emission, something normally observed in comets. This led some researchers to suggest unconventional explanations, ranging from exotic natural processes to, controversially, the possibility of an artificial origin. 3I/ATLS, however, did not cross that same threshold. Its unusual behavior was concentrated mainly in its early orbital estimates. As additional observations were gathered, the orbit began to stabilize. What once appeared nearly hyperbolic slowly transformed into a long, closed trajectory. Still, the fact that this confusion occurred again raised deeper questions. We are detecting more objects arriving from the outer regions of the solar system than ever before. Survey systems now scan the sky automatically. Telescopes are more sensitive. Detection algorithms are faster. Objects that once slipped by unnoticed are now being flagged daily. This marks a transition into a new era of astronomy. An era where the strange is no longer rare and where first impressions are increasingly unreliable. The larger question is whether a meaningful pattern is emerging. Are interstellar objects more common than we once believed? Or are we misinterpreting early data simply because we are observing more of the sky more often with imperfect tools? In the case of 3I/ATLS, the scientific consensus concluded that it most likely originated in the Oort cloud, an ancient object formed during the early history of the solar system, later scattered into an extremely long orbit. Unusual, distant, but still gravitationally tied to our sun. Yet the comparison with Oumuamua left behind an important lesson. Our ability to detect objects is advancing faster than our ability to fully understand them. Between discovery and explanation, there exists a narrow and dangerous gap where uncertainty dominates and assumptions take hold. And it's inside that gap that the most uncomfortable questions begin to form. If Oumuamua was real, if Borisov was confirmed, And if 3I ATLS nearly joined that same list, how many others have already passed without being noticed? How many interstellar objects crossed our solar system centuries ago, or even decades ago, before we had the technology to see them? And how many future discoveries will challenge our definitions before we are ready to interpret them correctly? Perhaps these events are not isolated coincidences. Perhaps they represent the first signs of a much larger population of travelers moving silently between stars. In the end, the question is not whether 3I ATLS was like Oumuamua. The question is whether Oumuamua was simply the first time we noticed. And if a pattern is already emerging in the darkness of space, we must ask ourselves one final thing. Are we truly prepared to recognize it?